A warm welcome to all of you. I'm Vrishali and we are learning power electronics and applications. In this session, we are going to study the TRIAC triggering using DIAC. If you remember, in our first unit, we have studied different power semiconductor devices such as thyristor, TRIAC, power MOSFET, IGBT, etc. So, we are going to see how this TRIAC can be triggered using the DIAC. But what is this DIAC? Let's have a look. In this session, we are going to discuss what is this DIAC, its construction, operation, VI characteristics, and how this DIAC can be used to trigger TRIAC. So basically, DIAC is a diode for alternating current. It is a two-terminal device, T1 and T2. Similar to TRIAC, it is a bidirectional avalanche diode which can be switched from its off state to on state for either polarity, positive or negative, of the applied voltage. It is a PNPN structure similar to TRIAC, and in case of TRIAC there are MT1 and MT2 and gate terminal, but in case of DIAC only T1 and T2, these two terminals are there. Talking about the operation of DIAC, if the T1 terminal is positive and T2 terminal is negative, this PNPN conducts. Also, if the T2 terminal is positive and T1 is negative, PNPN conducts. As I have said, it can be switched from off state to on state for both polarities of applied voltage. So let's see how this conduction occurs in DIAC. So the conduction occurs in DIAC when the breakover voltage is reached in either polarity across the two terminals. When the T1 is positive with respect to T2, and if the voltage V12 exceeds the breakover voltage, then the structure PNPN conducts. Similarly, when the T2 is positive with respect to T1 and the voltage V21 is greater than breakover voltage, then also the PNPN structure conducts. At the voltages less than the breakover voltages, a very small amount of current flows through the device. It is called as a leakage current. The leakage current produced due to the drift of electrons and holes. This leakage current flows in the depletion region, which is not sufficient to cause conduction in the device. The device remains practically in non-conducting mode. This portion of characteristics are shown in next diagram. So this is VI characteristic of a DIAC. So if you remember VI characteristics of TRIAC, these are very similar to that of TRIAC. So for this portion 0 to A, the device remains practically in non-conducting mode. So this portion of the characteristics is called as blocking state of DIAC. At point A, when the voltage level reaches the breakover voltage, the device starts conducting. During its conduction, the device exhibits negative resistance characteristic. The current flowing through device starts increasing and the voltage across the DIAC start decreasing. So this portion of the characteristic is shown by A to B. This is known as conduction state for positive half cycle. So if you remember, in case of TRIAC, we have seen a similar kind of characteristic. For this region 0 to A, as the voltage increases, the current still remain low value. But at the breakover voltage, when we start applying the gate current, the voltage starts decreasing as the gate current increases. And at a maximum value, a large amount of current starts to flow through the TRIAC. In case of DIAC, this gate current, this control signal is absent. So at point A, the voltage level reaches its breakover voltage and device automatically starts conducting. During this conduction, as this current increases, here we can see the value for voltage go on decreasing. The value of current corresponding to point A is known as breakover current. For negative half cycle, the similar operation may happen. The characteristic is obtained in the third quadrant. It will be a replica of obtained characteristic in first quadrant. This is because the doping level is same at two junctions of the devices. So in negative half cycle, till the breakover voltage, the negative value of VBO2, the current value will remain very low. After the breakover voltage, the device will start to conduct in reverse direction. So this represents the conduction state for negative half cycle. Once this device starts conducting, the current flowing through this is very high. It has to be limited by some external resistance. So this is all about DIAC. Now we are going to see how the DIAC can be used to trigger TRIAC. So the triggering of TRIAC can be achieved using simple DIAC circuit. A phase controlled circuit using TRIAC is shown over here, which is used to trigger DIAC. The goal of DIAC in this circuit is to ensure the TRIAC receives a very clean and fast trigger pulse. During the positive half cycle, when this P is positive, the TRIAC requires a positive gate signal for turning it on. This is provided by the capacitor C when its voltage is above the breakdown voltage of a DIAC. The capacitor discharges through the TRIAC gate, so the triggering of TRIAC makes it to conduct. When the TRIAC triggers, the voltage drop across the PQ will be 0 and the capacitor voltage will be reset to 0. A similar operation takes place when the negative half cycle. After some time, the voltage across C reaches breakover voltage in the other polarity. The DIAC again conducts. The negative gate pulse will be applied to DIAC when breaks down in the reverse direction. This provides an appropriate trigger pulse to turn on the TRIAC. The charging rate of capacitor can be changed by varying the resistor R. Hence, the firing of TRIAC can be controlled. Thus, the amount of power delivered to the load can be varied using this variable resistor R. Also, the phase control is achieved by varying this resistor R. But to have a control over the full range from maximum to minimum, the above simple RC circuit requires a very large change in the value of resistance. It presents a low control gain. So this is how the DIAC triggers the TRIAC in positive as well as negative half cycle. Now there is a small assignment to you. We have studied DIAC, its construction, operation and VI characteristics, and in the last unit we have studied TRIAC, triode for alternating current and diode for alternating current. Now you have to find what is the difference between TRIAC and DIAC. I hope you have understood how the DIAC can be used to trigger TRIAC. Till then, thank you, stay home, stay safe, and happy e-learning.